After hearing that there is no soup for you, these words travel through your ear and use inner neurons to travel to Wernicke's area. Wernicke's area is responsible for language understanding and helps to process these words. This information then travels to the amygdala again with inner neurons. The amygdala processes this information and decides to respond with anger, and sends a signal using neurotransmitters to the muscles with the intent to act violently. This signal travels through the inner neurons using action potential. In the area that action potential occurs, there is a phospholipid bilayer separating the cell exterior and interior. Within this phospholipid bilayer, there are two channels. One is a potassium channel and the other is a sodium channel. Next to these channels is a sodium-potassium pump. There are both sodium and potassium ions in the interior and exterior. During resting potential, only the potassium channel is open, allowing potassium ions to leave the cell, while the sodium-potassium pump works to balance the ions. When the signal reaches the axon, potassium channels close while sodium channels open, allowing sodium ions to rush into the cell, which causes depolarization as the interior is now positive. As the signal moves down the axon, repolarization begins and sodium channels close, while potassium channels reopen, allowing potassium ions to leave the cell and repolarize the cell. The sodium-potassium channel assists with this by working to bring 3 sodium ions out of the cell and 2 potassium ions in. However, after being processed in Wernicke's area, the words were also sent to the frontal lobe. The frontal lobe reasoned that the body needed a calm reaction and sent Gaba to prevent the amygdala's response from traveling through inner neurons. Gaba traveled through inner neurons to the amygdala, where an inner neuron transmitting Gaba intersected neurons transmitting the amygdala's signal. Gaba was released and blocked the neurotransmitters from the dendrites of the next inner neuron. When looking closer at this process, as the amygdala signal traveled down the axon terminal of an inner neuron, calcium ions attached to receptors to signal the release of neurotransmitters carried by vesicles. However, Gaba binded to the receptors on the dendrites of the next inner neuron, so as the neurotransmitters crossed the synapse, they were not able to be received by the next inner neuron. After it has stopped the neurotransmission, Gaba goes through reuptake back into the presynaptic neuron. As this occurs to all the inner neurons carrying the amygdala signal, the signal is stopped entirely and the body responds in a calm manner, not with a violent reaction.